Hello, in this video I'll be presenting to you our data lake project, which is to create a simple architecture including data ingestion, transformation, and exposition. For this project we'll be using two data sources, which are Reddit and SteamDB. We chose these data sources because on Reddit there are a lot of discussions about gaming, and SteamDB is all about gaming. It's a third-party website that retrieves data from Steam, which is the biggest platform of video games. And the goal was to visualize if what is going on social media, for example, discussions, trends, is it following what is going on in the media consumptions? And here we are looking at games, video games. So how all this project is structured. Here we have all the folders for our project, which is located in a virtual machine running on Ubuntu. The first folder is the Airflow folder. Then we have the Dash app, which contains all the components for our visualization. The data folder contains all the data that is scrapped in the raw folder. Then the formatted folder is all that will be formatted but is not yet ready to be used. And the usage folder will be containing all the data that is used in the visualization. The scripts folder contains all the scripts for the pipeline. And finally, you have the venv folder, which contains all our libraries installed locally. And the two last files are the README file, which will explain everything you need to know to install and run this project on your machine. And finally, the requirements, everything you need to install in terms of libraries. Alright, so now that we know how our project is structured, let's break down what we have inside of the folders. So first, let's look into the script folder. The first script which will be running is the SteamDB scrap. It is running using Playwright and Beautiful Soup. So how it's working, it will connect to SteamDB, launch a browser, retrieve all the game data, and then it will be stored in our data raw inside of a SteamDB games JSON file. Then we will be running our game names script. It is a necessary step before we'll retrieve the Reddit games. Why? Because the way that the games are stored, you can see here the name of the games have special characters. They have spaces and some special Roman numbers, and we don't want that. We have to normalize everything, because when we go to the Reddit scrap script, you can see that first of all we are using an API, not a scrapping method like we did with SteamDB, and we don't have a unique identifier between Steam and Reddit, so we had to find a way to join the same games together. And to do that, after we normalized all the games names, we used them in the find subreddit function. So what this function do, it will search through all the links of Reddit and use the normalized name to find the equivalent in a subreddit. So then it will collect all the data and it will make some pauses so we don't go above the time limit and be blocked by Reddit. And finally, it will save the data. The next step, once we have all this data scrapped, is to process it. So using our Reddit formatting script and SteamDB formatting script, we will use PySpark, so Apache Spark, to format all this data into a Parquet file. So it is useful when I have high volume of data, which will be the case knowing that it will be updating every day, so new data will be stored and we have to manage this correctly. As mentioned earlier, hence we have the game names normalized. We use them to share the same ID and we proceeded with a join to have our final Parquet file stored in the usage file right here. So we can look also into the processed files. So here we have all the parquet for the Reddit data and the SteamDB data. Now that we have all our data scrapped and processed, the next step is to use Elasticsearch to first create a template. So we have to map everything in our variables to be of the correct type, so we can use it without errors in the future. You can see here all the variables that were scrapped from Reddit and SteamDB. We have floats, integers, date formats, and once this is done, we can run the script of ingesting the data, so it will index into games database in Elasticsearch. And once everything here is ready, we can write it in our DAGs in Airflow, here in the pipeline data lake script. So here you can find again everything we just presented. Here you have the order how Airflow will trigger everything step by step. And we can then launch Airflow and look at it inside of the UI. First, let's initiate the database. Then we'll run the web server. Oh, it's ready. And lastly, let's run the scheduler. Alright, so let's open Airflow and look at it. Here we are in Airflow, so let's open up our project and let's go to the graph. Here you can see that it's already automatically running, and a little test we just triggered. And here we have the first successful run, followed by some other tests. In the graph, you can see everything that we showed earlier. So the scripts that are running in order, the SteamDB scrap, then the normalizing of the game names, the scrap of Reddit, all of the formatting, and finally the template and the ingestion made with Elasticsearch. So all of this pipeline will run automatically every 24 hours, which corresponds to the 24 last comments and posts that we can scrap from Reddit. So we wanted to stay consistent, but we can make this time shorter if we need to. Everything in Airflow can run either from the start when we don't have any data, or if we already have data, it will update consequently. Let's go back for a moment to our scripts and allow me to show you the Dash app folder, which is the folder for our visualization. It is entirely coded in Python. So the first folder is the assets, which contain the custom CSS code. It is entirely personalized. Then we have the components, which is the folder that contains the figures that will be generated inside of our visualization. We have the following pages: the home, the predictions, stats, trending, and also the script for the navigation bar. So the same pages are here in the pages folder. These scripts are to output what we generate here. So for example, if I take the home script page, the summary page table that you see here is generated in the figure home script right here, and then imported here through the components point fig home. So the same logic is used across all of the scripts to contain everything in a structured base. And finally, we have an interesting script, the query script, which is used to search through all of our data using our Elasticsearch database that we set up earlier. And finally, here is the entry point of our app. So let's just run that right now so we can visualize the results. Here we are on the homepage of our Dash visualization app. We are welcomed with a data table of our base overview. For this demo, we have about 700 games currently analyzed. Then we can see the most played games, which is here Counter-Strike with the number of players, followed by the most discussed game, games with the most members online, the last released game, and finally the last data was updated using Airflow. The next page is the statistics page. On this page, the database can be questioned and filtered using the input of the user. So for example, here we have a tree map, which displays the number of members for each subreddit. We can zoom in and navigate inside of the figure. We can also filter it and it will update it dynamically. If I want to see the subreddit with the most members inside, I can just slide here and it will update. The same applies to all of our figures. For example, here in the line chart, if I want to filter on the most online players right now, I can slide this. I can also select other filters as well, and it will update as I filter. So it is also here on the double axis, on the price and the rating. I can reset that. And also on the last figure, the histogram, which displays the most players on each game and the price distribution. So here we can see that the more a game is cheap, the more players it will have. Even if I move the release year, I think it will stay the same. The last figure here is the heat map, which displays the coloration between our variables. The blue ones originate from SteamDB, and the orange ones originate from Reddit. For example, here we can see that the peak of the numbers of players for a game is heavily correlated with the total members on a subreddit. So if a game was played a lot at some point in the time, we can say with confidence that the total members on this subreddit will be high. Another feature on this page is the search by game name. So let's type, for example, Apex Legends, but I purposefully make an error here, and the database will still retrieve the game. It is thanks to the normalization we made and the fuzzy option provided by Elasticsearch that enables to make some errors and it will still works. Like if I type, for example, Elden Ring instead of Elden Ring, it works. What it displays is some statistics about the game, such as the online players right now, or the peak of online players, as well as a metrics comparison. So it compares the statistics of the selected games against the mean of all the games in the database. For example, we can see that the follows for this game is of about 1000 players, and the mean follows for each game in the database is of about 180 players. We can also slide here right there so we can zoom on the variables we want to see and to zoom in on variables that are not on the same scales. For example, if I want to see the ratings, here I can see and compare with other metrics that are more on the same scale. The next page shows the general trending in our database. We have a generated podium of the most trending games today. It is measured by the last comments on the 24 hours, the last upvotes, current active players, and the overall rating. We also can see the top 10 most discussed game on Reddit against the top 10 games with the most online players right now. It is more interesting to compare them directly. For example, here we have a graph of the overhyped games. So it measures the games that are the most discussed on Reddit, but are the least played. So for example, the game Fairy Tales 2, we can maybe say it is overhyped. And finally, we have the prediction page. The figures on this page are displayed using machine learning models. So for example, here we use random forest regressors to predict the next most popular games. We train our data set and then using only the variables from Reddit, so the most comments, the most upvotes, and the most posts in the last 24 hours, to predict the most online players on Steam. So here we have the 5 games that we think will be the most popular in the next days. And the last figure uses the k-means clustering, which is a machine learning algorithm for unsupervised learning, which will cluster games through variables that are inputted by the user. So for example, let's select the total members and the online players and click cluster. The model will clusterize games. For example, here the yellow cluster corresponds to the games that are the most played and also have the most total members. We can reset here and select something else, for example, the price and the upvotes in the last 24 hours. And here we have the new clusters that are updated.